Hello, this video will briefly introduce the ConfigFix project, which is a conflict resolver for Linux's configuration language kconfig. These are the people involved in the project, with Patrick Franz being the main developer and Thorsten Berger and Sarah Nadi being the main supervisors. This project is our attempt at contributing back to the kernel community, whose configurator we studied a lot. ConfigFix is the product of over 15 years of research on analysis tools and the kconfig language. It is also part of the Kernel newbies ConfigSet project. At the moment, there is no support for setting an option with unmet dependencies. This can be a problem since some options have quite complex dependencies which can be difficult to understand, as can be seen in this screenshot. A user survey from a 2012 study confirms that activating an inactive option can be difficult for users. For 20% of surveyed users, it takes at least a few dozen minutes on average, and even for experienced developers, it can take a lot of time. ConfigFix is integrated into Xconfig. In this demonstration, we will use ConfigFix to set the option kvmproof MMU. Since under the configuration we're using, this option has no visible prompt, we need to switch to Show All Options. We add the option by selecting it in the menu above and then selecting Add Symbol. We set the desired value to Yes by using the button Y. More symbols could be added now by repeating the process. The set of options we want to be changed is called a conflict. We click on Calculate Fixes, and after about 15 seconds we can examine 3 different fixes that would set kvmproof MMU and fulfill its dependencies. A fix can automatically be applied by clicking on Apply Selected Solution. The fixes are generated in a multi-step process. First, the kconfig model is translated into a propositional formula. This formula is then converted into a set problem. Subsequently, the values of the current configuration and the conflict, that is, the changes in symbol values, are added to the set problem. We then use a set server to check the satisfiability of the set problem we built. If it is satisfiable, then that means that the options can just be set using the regular GUI. If it is unsatisfiable, a conflict resolution algorithm is used to generate a maximum of 3 fixes. We evaluate the ConfigFix with regard to how many conflicts it is able to resolve and the quality of the generated fixes. The testing framework we developed uses randconfig to generate random configurations. In our evaluation, we generated configurations for 3 different architectures and for 9 different probabilities for an option to be selected, ranging from 10% to 90%. In total, we therefore evaluated 27 different configurations. For each of these configurations, we generated random conflicts containing 1 to 10 changes. The results can be seen in the table on the right. The most important results are that about 85% of the generated conflicts could be resolved, and that almost all fixes that were generated actually do fix the corresponding conflict. Thank you for watching.